Good afternoon, ladies and gentlemen, and other types of people. My name is Slobodan Djordjević. I am professor of hydraulic engineering here at the University of Exeter, and it gives me a great pleasure to open this 25th anniversary of the Center for Water Systems event, which we smartly titled Advances in Water Research and Innovation, 1998 to 2023 and beyond. I'm legally obliged to start with few housekeeping things. So no fire drill is planned for this afternoon. So if you do hear the fire alarm, please listen carefully to the voice message and make your way to your nearest exit. A few here, a few there. And proceed to your nearest muster point. So that's a bit of a military terminology we are using for this purpose. Which will be, well, both piazzas and on one and the other side of this building. That's about that. So, firstly, you will be welcomed by Professor Lisa Roberts, who could not be here.
Hello, and welcome to the University of Exeter. I'm Professor Lisa Roberts, the President and Vice-Chancellor of the University, and it gives me great pleasure to welcome our alumni, colleagues and guests to this Exeter Centre for Water Systems event, Advances in Water Research and Innovation, 1998 to 2023 and beyond. Today we're celebrating the 25th anniversary of the world-renowned Centre for Water Systems. And whilst I am so sorry that I cannot join you in person today, I'm very excited that over the next 2 days you'll be able to hear about many achievements of CWS and of course have the opportunity to discuss future challenges and gain new insights into the latest developments in water engineering related subjects. Just as importantly, you'll also have the chance to meet up with old friends and make brand new connections. I know that many of you there in the alumni auditorium today are past or present members of the CWS, and I also know that some of you have come here today from as far away as Uganda, China, and New Zealand, as well as from several European countries. But wherever you come from, I'd like to thank you for being here to maintain, strengthen and establish new links with our university. For some time, the CWS has been the largest single unit academic research group in water engineering in the UK and has now produced more than 100 PhD graduates. Many of them themselves are now experts and distinguished leaders in academia and industry across the globe. And the work of the Centre is having a huge impact globally. Earlier this summer, the Global Times Higher Education Impact Rankings placed Exeter as the very best university in the world for our progress towards delivering the UN Sustainable Development Goal 6 on clean water and sanitation. And that important ranking is testament to the amazing work of the CWS, which, through its numerous projects on every continent, strong engagement with industry, and partnerships with local communities, national agencies and international bodies is a key contributor to this fantastic accolade. Everyone here today should be so proud of that accomplishment. I'd like to extend my heartfelt thanks and congratulations to you all for your input and support. And the work of the CWS is of course a crucial part of our university's mission to create a greener, healthier and fairer world. And I'm delighted that we're able to make such a strong contribution to this through the work of the CWS and many others at the university. I'd once again like to welcome you all to our community. I hope you have a wonderful time in Exeter. Thank you so much for coming, and I look forward to continued collaboration as we look to tackle some of the greatest challenges facing the world and develop solutions to them together. Have a wonderful day.
due to the nature of this talk, you are not in a position to ask questions, but please do so with all the remaining presentations. So you have seen the program. We have a number of presentations by distinguished speakers and some younger colleagues. We hope that there will be time in the selected slots to ask questions. We have means of making you sound strong, so we'll have different types of microphones, including a ball, catch box, which we'll be throwing around. So please don't hesitate to take part in the discussions. It's my great pleasure to announce the first speaker, the first proper speaker, Professor Emeritus Godfery Walters, a founder of the Center for Water Systems.
Oh, thank you for inviting me, Slobodan and David and Dragan and everyone else at the Centre, for inviting me back to this 25-year celebration. It's actually 15 years since I left the Centre and the university and retired. So I was only part of the Centre for about 10 years, remarkably enough. What a 10 years that was. And it's great to see so many of the old faces from my time, some of whom I actually recognise. And it's actually quite good to have these large tabs. You actually see people from a distance without sort of crouching up and seeing what their name tab actually says. So thanks for that, organisers. And it's also so nice to see a whole lot of new faces. Whether they should be new ones or not, I'm not quite sure at the moment. But yes, so many of you have turned up today. That's great. One face I know very well, of course, is that of my daughter Sally, who is with me today. And you might ask, no, it's not Bring Your Child to Work Day. And she is not my carer, at least not yet. So she's here in her own right as a former employee and graduate of the Centre. We've established it was 2004 to 2008, her total time here, and as a prominent and very successful water engineering consultant in Exeter. You can all hear me okay? Yeah, good. So, as well as meeting up with old friends and colleagues, which of course is the main purpose of this get-together, I'm here to say a bit about the early years, how and why Dragan and I set up the Centre of Water Systems back in 1998, and what led to it. Also, a few words on why I think why it has been such a major success. Back in 1998, our main research interests were in evolution-based optimization using genetic algorithms and similar computer-based techniques such as genetic programming and other ways. And this was mainly concentrated on the optimal design and operation of water systems, with probably about 15 members in our group. But that was in 1998. How did we get to that point? Because we had then a fairly active research group, rapidly expanding. Well, going back 5 years, I was just about the only academic in the university with research interests in water systems, and certainly the only one with interests in water systems and optimization. After several years of research, looking at very early work going on in Germany on evolution strategy, that's in Berlin, and pioneering work in the United States on genetic algorithms, I managed to obtain a 3-year research grant from the SERC, the Engineering Council, as it was then, to develop genetic algorithm methods for optimization in the water and gas industries. This allowed the university to employ a postdoc researcher to work with me for a 3-year period. I had a visiting academic, Jim Davidson from Canada, at the time, and he recommended to me a former colleague, a certain Dr. Savić, and that is how Dragan came to Exeter. Within a couple of years, Dragan had joined me on the lecturing staff here, and we were now a proper research group led by 2 academics, pursuing a potentially very interesting and industrial relevant topic that was just about to take off internationally. So back in 1998, what was going on research-wise in our group? That's actually quite difficult to pinpoint. You've got publications, we've got research grants recorded, but thinking back to it, it's quite difficult. But I have a group photo of what group we had in March 1999 with 12 people on it, probably not all the group, and people like Mark Morley, Roger Atkinson, Jenny Thorne, Werner de Scheetzen, Florian Bessler, Cobus van Ziel, Mark Engelhardt, Zoran Capellan, Dragan and me. So a couple of others whose names immediately don't really immediately come to mind. So we had an active research group of about 15 staff, students and visitors, many of whom are here today. Our research was branching out from genetic algorithms to include other methodologies like data mining, genetic programming, possibly multi-objective optimization. I'm not sure when we started on that. Exploring computer techniques like parallel processing to get the best from existing computer power. Applications to mainly, but not exclusively, water-based systems such as water distribution network design, strengthening, pressure regulation, quality control, leakage detection, network calibration. We're also looking at sewer systems, things like reservoir operation, pump scheduling, etc. So anything basically that you can model on a computer, we would have a go at trying to optimize. We had by then started our very important relationship with Ewan Associates to develop and implement genetic algorithms for commercial application. But more about that later from Andrew Southall. We had major new funding from the UK research councils on genetic programming. We had teaching company schemes and so on. We had individual studentships sponsored by industry and by overseas governments and the research councils. So a lot going on with Dragan and I heading things together. I have a memory of about 25 years ago, perhaps 25, maybe 26 years ago, chatting with Dragan over lunch or dinner, I'm not sure which, in a former Soviet-era hotel in Prague. Can't remember exactly why we were there, probably one of many meetings about industrial, academic, European partnerships. We agreed that the time was right to give our rapidly expanding research group a proper focus and the recognition it needed, both internally within the university, but more importantly, nationally and internationally, to continue its growth. We chose a name for the centre. We chose Centre for Water Systems, which is CWS for short, not to be confused with a well-known retail group at the time, the Cooperative Wholesale Society. Produced a logo and away we went. So after that, our newly branded centre, with Dragan and I as co-directors, expanded ever more rapidly, with further EPSRC grants, including platform grants, European Community Framework grants, knowledge transfer partnerships, and industrial support. The group's research interests continued to widen, including all areas of water systems and hydroinformatics. But I will leave that to others to say more. So that gives a very brief account of how the Centre for Water Systems was formed. And a bit about what I remember of those early days. No doubt others will take the story forward and fill in a few of the gaps. So why was it successful? So what is success? First of all, the university might measure it in terms of research income and published papers, and we are certainly well up in obtaining both a large amount of research income and a large number of quality publications. But on a personal basis, the experiences of our staff and students were very positive. And looking at their progress and careers, I am certainly very impressed with some of the way that many of our graduates from the centre have turned out. So I think we managed to attract and choose the right people, students, research staff, lecturing staff, to develop a friendly group of very talented individuals from a wide variety of backgrounds. I remember a barbecue garden party that Kate and I had at home with maybe 25 people, 30 people from the centre. And we had in that, we counted 15 different nationalities and almost as many different languages. So we had the right research area also at the right time. Evolution-based methods caught on worldwide, and research mushroomed globally. At a time when computational ability was increasing very rapidly year on year. So we were able to simulate industrial scale problems and do the optimization of these industrial sized problems in a sensible amount of computing time. We had amazing support from Ewan Associates, Vince Ewan, Andrew Southall and others, with collaboration from many of the water companies, South West Water, Yorkshire, United Utilities, and other consultants like Binney Black and Veatch. Branding as a centre was an important step forward to us to achieving recognition within the UK and globally. We ran a Computer Control and Water Industry 99 conference here at Exeter just 1 year after we'd formed the centre. And that put us even more on the map in terms of recognition. I found that to be a very enjoyable and, to me, quite a successful conference. And it was very much a family event for me, because my wife, Kate, supplied all the conference goods. I noticed at least one person today has still got one of the bags. And the pens I've still got at home, and most of them don't work now, 25 years later, but she provided that lot, and Sally and Andrew, my son, helped as well, as Sally reminded me. So we had, and hopefully still have a certain amount of academic freedom in those days to pursue new ideas and the ability to get individual research funding to develop those ideas, as well as access to major collaborative programs across the United Kingdom and Europe. Finally, we had a university with, at that time certainly, and I hope it is still now, relatively little bureaucratic red tape in terms of doing what we thought was the right thing to do. It had a growing reputation for teaching and research in a city that provides a safe and attractive living environment. All those, I think, contributed to our success. So those are my thoughts and memories, and sincere apologies if there are some important errors or omissions. I have been retired for nearly 15 years, so I'll step back now into retirement and pass you on to my personal representative of the next generation, my daughter Sally, to say a few words about her experiences in the early days of the centre. So it's great to be here, and keep up the good work and enjoy the celebration. Thank you.
Thank you. Whilst it's not Take Your Child to Work Day, there were certainly many of those throughout my life. I think my life and my sort of connection with Exeter University certainly goes back, probably predating even being born. My father started working here whilst I was sort of still forming. Anyway, I wasn't here to talk about that. I was here to talk a little bit about sort of my experiences for the centre. So firstly, thank you, Father, Professor Walters. That seems very strange to say, and standing here on a stage following in my father's footsteps is not something I ever really envisaged. I'm a little bit nervous, probably the second most nervous I've ever been, because I can remember giving a conference paper in Vienna with my father sat in the audience, and I think I was more nervous about his critique of my research than the academics there present. So again, a bit like father and daughter, we've both come with our paper. We're not very digital, I'm afraid. It's a pleasure to stand here, and thank you for inviting me. I'm going to pick up the baton and talk about my experience of the Centre for Water Systems official capacity. I'm going to talk about what I actually call the golden years, because, you know, that was when I was here, from 2004 to 2008. I think my father alluded, my involvement with the centre actually started back in 1999 when I did a summer placement. You could call it one of those Nepo baby moments when I got given a sort of part-time summer job whilst I was still at uni, my first year. But I had a wonderful summer placement running those wonderful genetic algorithm simulations on the computers. That actually involved me spending my summer sitting in the computer lab on the second floor of Harrison Building, rerunning about the 40 computers at that time, taking out the disks, saving the simulations, and then creating another mutation. It was fun. It wasn't quite as advanced as today. But I was also involved in this conference prep, editing your papers to fit into the boundaries of Word at that time. And I think Jenny was also involved in that, and it was a particularly wonderful summer. But I officially became involved in the centre in 2004 when I actually joined as a fully fledged member through a Knowledge Transfer Partnership Associate. I applied for the role. I'd been in construction and wanted to move away from working sort of costain on site to coming back into sort of still finding my feet and where I sat within the civil engineering community. So I joined Exeter University on a KTP associate transfer. It was an industrial partnership with South West Water and Exeter University. And I spent my time, it was looking at research and optimisation around sort of data management for small wastewater catchments. And I was going to pick up on the first changes I noticed in those 6 years, well, the 5 years from 1999 to 2004 when I've been away and come back to the centre, was really how big it had grown. And I joked about in 1999, I was running between the second floor labs, the offices on the fourth floor, getting a lot of exercise in the Harrison Building, but everyone was fairly disparate at that point. When I came back in 2004, I was surprised to see they'd actually moved to their own dedicated sort of corridor, I think, at the back of the labs on the ground floor, or, you know, the floors, how they go. And I can remember sort of being really impressed that they had actually multiple meeting rooms, multiple sort of offices, and sort of their own labs. And actually the number of staff had grown phenomenally. The sort of the teaching staff, the research staff, the PhD students, visiting professors, as well as the scale of sort of the research grants and the studies and sort of international projects that they're working on. It was phenomenal to see that growth in those sort of short 5 years that I've been away. And yeah, it had really started to cement itself, or had cemented itself, not just nationally, but internationally with that reputation. So I was really, really quite staggered, and that was my first impression back in 2004. So over the 4 years that I was directly linked to the centre, the KTP was about 2 years, wonderful experience. I got to present a technical paper at a conference in Vienna, went to the World Water Congress in China. I didn't present there, but managed to attend. I then completed an MPhil, and I'm sorry to say I didn't quite have the patience for a PhD, so I don't know if there's anyone else in the room, but I might be the only unique person with an MPhil to my name. So sorry, Dad, I didn't quite follow in your footsteps. But my lasting and resounding impressions of the centre was around the people, the culture, and just the pure passion for the research that people were doing. So on the people, I was always made to feel included and to be part of the team. And that was quite unique because despite, or maybe in spite of who I was, but also the fact that I was based remotely at South West Water probably 4 days a week and only at the university about a day a week. Every time I came to the offices, I was included, I was welcomed, I was included in the social events, and everyone was extremely supportive and actually very tolerant, maybe of what might have been some of my very stupid questions. But the culture, that implicitly came from the people and from the university. It was one of, I say, quiet dedication, support, and such a community and just mutual respect. So everyone was really supportive and, as I said, just really welcoming and really, really tolerant. And it was a great environment and very sort of researchy. And that brings on to the passion. I was going to say the phenomenal level. Did suggest geekiness, but I'm probably in the wrong place to say geekiness right here, right now. But and I'm quite an engineering geek myself, so I can't really comment. But that phenomenal level of intelligence and commitment and passion to the work and the research being done, and obviously to teaching and to continuing teaching was just phenomenal. I was inspired constantly then, and I'm still inspired now by the work that's continuing and seeing the sort of the next generation and the evolution of all of that. So my time at the centre really helped me. I grew phenomenally. My academic, my industrial knowledge and placement, but also sort of as a person. You know, I came out with a sort of a degree. I came out with sort of, I've got a paper to my name, I think only one, but I'm a co-author on another. I presented at international conferences. But also what it gave me was a complete understanding of the real importance for that research and industry links. And I think Dragan's going to talk a little bit about it a bit more. But for me now, in my role in consultancy in the water industry, that's really, really important. And those are fundamental links. So to conclude, I'm really not surprised by the success for the centre. It's been fantastic to seeing it evolve over the years, from the concept and the passion of my father and Professor Dragan Savić, through to that enduring, thriving centre now that it is, and that internationally renowned centre. So those are my observations. It's been fantastic to see the growth and to see it, and long live another 25 years. So thank you.
Thank you, Godfery and Sally. Are there any questions for anyone? To carry on time. So it's my pleasure to introduce the next speaker, Professor Dragan Savić.
Thank you, and I would also like to extend the welcome to everybody. It's so good to see so many familiar faces. This is why we are here today, really. Godfery and I think Sally both says family affair, and this is really what Centre for Water Systems is known, or at least that's how I feel about it. I was saying to Godfery this morning that I blame him for everything because he started it. But I also, to be kind of in the familiar situation, I blame Sally as well, because of her. My daughter went to the same school as she went because she was taking her around on an open day, and then she decided to go to a very expensive school. Anyway, that's a little bit of a history. Well, I had to go back to the website, and this is, I think, a contribution from our colleague David Butler here, who we wanted to create a mission for the centre. And this is, I remember this word though, operationalizing. I can't even pronounce it today, but it is what we as engineers do. This is a Center for Water Systems Science and Engineering. We want to be close to practice, industry, as much as possible. And, when you have those mission and vision statement, you have to know who your client is. And these are our clients. We worked with water utilities, all the consultants the UK used to have, now they're all American. The government, the regulators, Commission, European Commission, and also we work for the public. Being in the Netherlands now, that public ethos and sense is very, very strong in the water sector. So I was given this, why do we work with the industry? We need to work on a problem. That's what engineers are supposed to do. Even if there is no problem, we'll create one and then solve it. Innovative research is what drives the industry. We need to make fast progress. Climate change, everything that we're dealing with requires us to act fast. Impact, and I don't mean university way of looking into impact. So that's what we need. That's why young people are working on their PhDs to make impact on the society. So we don't have to invent problems that we solve. Access to resources. Godfery was talking about that because it is important that through the industry you can get that leverage in order to get external grants and funding for your research, and also from the industry itself. Career development. I think I don't need to emphasize this one. Everybody in academia is there to advance, and it's not just academia, obviously, in industry as well. So that link with industry will help you with, and obviously real world applications, because again we want to solve real problems. Godfery alluded to this about how do we work with the industry, and we started and huge help from Ewan Associates and the local office run by Andrew here. But why do I say build trust? Because it took me like 6 months to get some data from Andrew. Who is this young guy? He wants some data. And he gave me the report on the calibration of the water network of Tiverton. And that's how it all started. Godfery gave me the opportunity to work on it, Andrew get the real data, and we moved on from there. So we started building trust. And then his colleague and boss, owner of the company, Vince Ewan, who is this other guy here, he started kind of trusting us a bit more. So then we developed this commitment to collaboration. They started investing in teaching company schemes to see what these genetic algorithms can do for them. And transfer of knowledge, that's what now they call them, knowledge transfer partnerships. They used to be teaching company schemes, isn't it? And also this understanding the boundaries. We at the university, we are not in the industry. We're not mostly in that mode. We have to understand what their constraints are and what their needs are. But we are there to push the boundaries from both sides and with respect and kindness. And that's all we got from these guys. So this was very important for the center. And I managed to rescue from some old web pages, the web page of Ewan Associates at that time, with a division that they created to explore the technology we were developing at the university, and it was called Ewan Optimal Solutions. And we started with unpaid pilots. Bristol Water came, Paul Fanner, if that rings a bell with anybody. He came with the Bristol City pipe network and wanted us to calibrate it through, and then we managed to do that, and they were very happy. And then from that one-to-one engagement, and when I said one-to-one, that was with you, and we started talking to others, and the others started to give us more opportunities to show what we could do. So this is just a couple of examples of how the things develop. This is the grant that Godfery was talking about. Those familiar with EPSRC, before that, that was SERC, Science and Engineering Research Council. So Godfery managed to obtain that grant, and it was genetic algorithm for gas and water industries. And after that, there was EPSRC special vehicle called WHITE, Water Industry Technology, something like that. Yeah, I'm looking at David, but yeah. Anyway, we were successful in getting another project that was looking into whole life cost approach to water distribution system management, basically asset management. And we employed a postdoc from Australia, from the University of Adelaide. We have many colleagues there that we collaborated over the years. His name is Mark Engelhardt. And with another colleague from Sheffield University, Pete Skipworth, they actually spun out a company, a spin-off called Seams, to do asset management. And during the project with these industrial partners, they already got kind of their fingers into the industry, and they got the funding directly. And I remember $500,000 they get at that time, and that's what gave them the push to set up the company. So Universities of Exeter and Sheffield took shares in the company. That was followed with by another project now working for whole life costing in the sewer systems. 2018, Seams was sold to one of the largest, I was going to say UK, but no, it's a Dutch and international consultancy company, Arcadis, to strengthen their digital offering. And we use this in the REF 2021, Research Excellence Framework submission, as our impact case study. And apparently they got pretty good ranking. And if you're looking into, again, how we started with research and ended up with that impact, we also had another project that we've, EPSRC funded project, started in 2010, that was preceded by quite a lot of different grants in the flooding, flood modeling, flood risk analysis area. It was CORFU and Flood Risk Management Research Consortium 1 and 2. And that grant led to further work with a different type of industry. And this was insurance industry. We did a consultancy for Munich Re, for Swiss Re, CMCC in Italy, and few others. And that, again, was followed by another KTP with ICS Consulting. We were nominated for some few awards. That went into really huge impact, where Torbay Council was joining our European project, and they also got the funding based on those results to increase the flood protection schemes in Torbay, to spend 3 million and to save like 70 plus million in flood costs in terms of impact. So we submitted this as well as an impact study and impact for the REF 2021. And again, we are currently, or the colleagues from the center are currently in the process of spinning out another company, this time with a major UK insurance group. So real kind of footpath from ideas through research grants into industrial impact. This is just to remind Godfery, I think, and everybody else of early days. Well, a lot more hair on all of us, particularly me, I think. Yeah, the ties were really brilliant. Anyway, the idea of these knowledge transfer partnerships, and I spoke to some new KTP associates here, is to get, that experience in the industry, being employed and security of the university, and being co-supervised by leading academics in the UK. So we had lots of them with UN, with ICS, with Hydro International, Artesia, Southwest Water. So these are just three examples of what people have developed, these KTP associates on various projects. For Hydro International, they were using CFD and genetic algorithms to improve the product development. That one was assessed as outstanding. Southwest Water, the recent one with Zoran and his team on using AI and machine learning to detect and classify sewer faults. ICS Consulting, we did a 2D fast modeling tool to model risk from your own kind of assets. If main breaks, what will be flooded? And a good reminder is a couple of days ago in New York, Times Square was flooded by a main that burst in a city like that. Anyway, that also spilled into education, linking education in research. We have this industrial doctoral center for water sector, STREAM, IDC, with partners from Cranfield, Sheffield, Imperial College in Newcastle. And the point here is that we had so many inaugural industrial partners and sponsors, but many more joined later. So they were funding half of each of those engineering doctorates. And you can see 97 researchers who graduated from that program. So those are the people who spend most of their time, not at university, but at the partner, industrial partner during the IDC. And then the one that was led by ourselves, or still is by ourselves, it's the one on the water informatics and science and engineering. And that one with Bath, Bristol, and Cardiff. Again, we have lots of academic collaborators for that one and huge support from the industry, and also with 70 plus researchers that benefited from that program. So CWS, the CWS and the industry. Well, the engagement with the industry was and is still essential to the success of the centre. We wouldn't be as successful without that engagement and support. And again, I think, the impact that I can see is that we had positive impact on industrial investments and practices. I mean, that example by Torquay, long time ago when we worked initially for the region of York, 30% saving on 150 million investment, huge. I wish we worked on percentage. And the last one is obviously for the university. And I think the Vice-Chancellor, the current Vice-Chancellor, she alluded to that, because the center is what I would call a university's crown jewel. So I'll finish with that here. Thank you very much.
Okay, I think now is the time to challenge the speaker. So who would like to start?
Maybe on timeline, nothing.
Ask a question then. The Wise Doctor Training Center by the 4 universities. Do they have like a short title for the group?
Yeah, but you have to remind me what it is. I know that they have some kind of organization, but what is it called?
GW4?
Great Western Research.
Great Western 4, full stop.
4, okay. Yeah, well, yeah, it is. Yeah, it doesn't have research, otherwise it will be GWR, which is the Great Western Railway. Yeah, sorry. I've been away for 5 years and forgot all the acronyms, Slobodan.
Just a second, please.
Thank you, Dragan. That was fascinating. Did the centre grow organically, or was there a master plan that you followed to bring it to where it now is?
Yeah, I wish I could say there was a master plan, but no, it was totally organically. As Godfery said, we just at one point decided we need to a moniker, we need to something to call ourselves, to be able to muster some support, and also to be able to give recognition to the members of the center as part of that larger group. That was it. Obviously, over time, we had more strategic kind of discussion. How do we go forward? But people heard of us and wanted to come and visit, wanted to do a PhD where the Kobus is. I have never met him before. He applied for the post. He got the scholarship and he said, I want to come to Exeter. And that was with quite a few people around here.
Anyone else? Don't be shy. Can you have those balls, please?
Oh,
my leg
cubes.
is a bit tired.
Dragan, great presentation. Takes me back quite a few years, for which I'm not going to thank you. You've alluded in your presentation to the importance of links with other universities, with industry, and other centres. But what I haven't heard you say anything about is links within Exeter University with other departments. I know other centres in other universities do make an effort and involve other departments in their work. I just wonder if you'd like to comment on that from your perspective. Thank you.
That's a very good question, Adrian. We worked with other centers, individuals within the University of Exeter, and at one point there was an idea of cross-departmental center, and would you believe it? It's being actually inaugurated very soon. That's something called the Crew Center, but don't ask me what the abbreviation is. It's a joint venture between the university and Southwest Water. Its joint investment is over 30 million. Because I've been away from the university, I don't know the details, but I'm now being engaged as an external, so I'm sitting on the board, advisory board. But yes, that is happening. It was haphazard, I have to say, previously, because I find it, if you're not in the same building, it's not happening as you would want. Computer science moved into the Harrison building where engineering was originally only in that building. And we started collaborating with computer scientists. Mathematics came in next. And again, the collaboration happened. So I blame the expansion of the university that we lost coffee meeting rooms. You know, we used to, when I moved here, we used to have, oh no, he's going to talk. Yeah. Well, we had a coffee, well, should I say coffee lady? She would come at 10 o'clock. We would sit in that room. We talk to each other. Now we are all in our offices, and it's very difficult to arrange that unless you go and push yourself for it.
I would just add that we did work with people, colleagues from medicine, geography, biosciences, business school. So, sorry?
Psychology.
Psychology, yes.
Yeah.
So there is a list, but they have not become members of the center. So, thank you very much, sir. The next speaker is Professor David Butler.
Thank you very much. Good afternoon, ladies and gentlemen. A very warm welcome from me to add to the welcomes that you've already had. I was just thinking about, as Godfery and Sally were talking about, the family, the CWS family. I wasn't born into the family 25 years ago, actually. But I was thinking about, no, I wasn't born, but I was adopted. I was adopted, amazingly, 17 years ago. So it's been my privilege to be part of that family over the last 17 years. So what I've been asked to talk about is UK research, and what that means in practice is UK funded research. So I'm going to talk a little bit about those funders, who they are, some numbers, not too many numbers, what research topics do we deal with briefly, and then a quick canter through the years on some of the research projects that we've been doing, funded by UK. So here we are. Here are our main research funders. I've dug through the annals of the University of Exeter's finances and found these numbers over the last 25 years, which is not easily done, but there they are. You'll see our main funders there. UKRI is the main funder. The Engineering and Physical Science Research Council comes in at 38, but you'll see a number of other funders all the way around that list. I suppose actually industry at 52 comes out as the main funder. But in terms of the Research Council, EPSRC is our main funder, and you'll see many others as well. So quite large numbers over that 25 years. How does that break down? Well, again, done some more ferreting around. You've already heard this number, I think, today, total number of PhDs. We're pretty much at 100 over the last 25 years, 100 PhDs. So that's 4 per year, isn't it, if you do the numbers. Total numbers of staff publications, these are separate publications of the existing staff group, well over, we think, 2,300. So what's that? You know, roughly speaking, it's about 100 publications a year, nominally, isn't it? At least 20 best publications. Best paper, what's that? 1% of our publications have been awarded bests, as it were. And then some fellowships, awarded fellowships, funded fellowships. And you've heard a little bit about CCWI and quite a few other conferences we've run over those last 25 years. So that's what I'm going to say about numbers. And you notice I have not put anything about money, about pounds, about euros, or about dollars. I don't want to talk about that, but I do want to talk about the extent of our research, and I hope you'll see the importance. Now, in terms of topic, how on earth do we define what it is that we do? Well, Dragan has given a nice one-line definition of that, but what I did was I took the titles of all 35 EPSRC projects that we've been awarded and put it in a word cloud to see what comes out. So this is what we say that we do. And I don't think it's any surprise to anybody that the big E is water, obviously, clues in the name, isn't it, really? And there's systems as well, of course. But what else is on that list? Management, optimization. There's a thing. You would have never guessed that one, would you, optimization? But flood, risk, environment, urban, modeling, and so on it goes on. So that gives some idea of the extent and breadth, and to a certain extent our focus really over those 25 years. Now I'm going to do a quick canter, as I say, through some of the funded projects over those 25 years. Apologies to colleagues if I've left your pet project out, because I've had to, and apologies to other colleagues if I don't explain your project correctly that you did 20 years ago. This one you've heard about already, and I need to start here. Technically, it's out of scope because 1994 to 96 was before the start of the centre, but I think I had to mention it because it was a seminal piece of work. I think you'll agree it was really the first use of evolutionary computing, genetic algorithms in particular, in so-called real water distributions. And you'll see a nice plot there of minimizing an objective function, cost, and a nice convergence, and the development of GANet. GANet has had a life of its own, really, since then, has gone on to be developed. You produced a nice Excel add-on as well that was used in its time as well. So, and a lovely publication that's seen a lot of citations ever since. So really, I think, or another reason I picked this project was it was the first time I'd heard of Exeter. Not Exeter, Exeter University and the work that they were doing in this field. I want to pick up another one that Dragan mentioned because it's part of the development of the centre, 1999, 2001, the whole life costing approach to distribution management. And as Dragan mentioned, this project was all about asset management, and it was quantifying the whole life costs of operating distribution networks, and development of a piece of software called Wilco, I think it was. And you'll see the interface there, which is very kind of late 90s type interface, isn't it? But that's how it was at that stage. And this was a very interesting piece of work because it kind of linked together asset management, asset knowledge, and operational performance. Let's put it like that. So linking those three things together, and helping companies establish their cost profile over time. And then this particular profile, I think here, it was a minimum activity type profile, which shows how cost was low to begin with. We're not spending any money, but of course it all comes home to roost later on if you don't do your maintenance, i.e. costs spike up later on. Platform grants at that sort of stage, 2001, 2005, were really important investments by the research councils in promising research groups. Exeter got one of those. I had the privilege of getting one at Imperial College at about the same time, actually. And the good thing about them were that it allowed us to have base load funding, not specific project funding, but it funded the centre to do good stuff. And certainly Exeter here, CWS, did good stuff at this stage. And this particular piece of work, Zoran's work, early work, was developing robust methods of optimization. I love that diagram on the bottom right. Just shows very nicely how not to do optimization without considering uncertainty. You may get your maximum and your minimum, but if any of your parameters are off to any extent, you'll crash and burn. What we want are those, maybe not absolute maxima or minima, but sit on a nice rounded hill so you don't lose your performance, even if things go slightly wrong. Interestingly, and well done for getting the next project on whole life costing, but applying it to sewers. I don't know whether you found it that way, but I think that's probably slightly more challenging to do that just because of the way sewers operate. But what I found quite fascinating was you used the same basic methodology, but applied it in a slightly different way, a developed way. And you'll see that the graphical user interface has kind of improved a little bit. And the really important thing about this piece of work, and Dragan has alluded to it really nicely about how it was taken into practice through SEAMS. WAND, Water Cycle Management for New Developments. I picked this one because this was a project I had as I arrived 17 years ago. And WAND was quite a large multidisciplinary project and was really focused on new housing developments and how we could manage water more appropriately at that scale. It included the development of a tool. What I've shown there is just a diagram of a MATLAB Simulink version of it in its early days, called UWAT, Urban Water Optioneering Tool. I think that stands for. And the idea there was that it would allow us to compare and, yes, to optimize the performance of the type and scale of water management at these relatively small urban developments. And you can see some of the results there on the bottom left, where we've shown how, compared with benchmarks, we can optimize performance and reduce water consumption. That led on to the development and the writing of a Syria best practice document. Andrew Southall was involved in that as well. And that's gone on to be used in the outside world. FRMRC were two large projects focused on flood risk management. These came about really after the really horrendous flooding in the UK at that time in the early 2000s. So there were two projects, the first FRMRC and then a second one. The work that we did at Exeter here really showed how, and at this stage we couldn't do this, but it showed how we could couple the underground hydraulics of our drainage systems with the above ground hydraulics of flooding. So it was a 1D, 2D coupled model, really the first in the UK. Of course, that's gone on to be used and developed in commercial models and is now widespread. And also of interest is that interface, which we never really thought of before until this time, of what happens when our systems surcharge and overflow onto the urban surface. And what about the interactions between the pipe flow and the surface flow coming out and, of course, going in. And you see some nice work there looking at using CFD to model that interface. Here's another one. I picked this one to highlight because it was a project led by Cambridge University, not because of that, but because it was led by their planning department. So we were partners in a consortium led by planners. And planners speak a different language, as you probably know, or their own language. And they also use different models. In particular, they use LUTIs. I don't know if you've come across a LUTI. It's, I'm going to have to read it, a land use transport interaction model, because their world is all about land use, urban growth, and transport infrastructure, because they see transport infrastructure as the big generator of economic growth. So we had to, this project was about integrating that with infrastructure. So we had to come up with a way of getting us to talk together. So to do that, we developed a whole system of tiles. So we turned our growth plans, the planners' growth plans, into reproducible tiles of certain types of development, terraced houses or semi-detached houses or whatever. And then we could use that in our UWAT, in our optioneering tool, and in our urban growth models. So that was a fascinating project to work on. And I'd like to do more, actually. And if you get the opportunity to work with planners, because they are so influential and frankly so, let's say, naive about the water systems that they deal with, it's really important that we do. Cadiz has been mentioned by Dragan as well. This project, 2010-2013, was to really exploit the potential of cellular automata, which of course have been around for a long, long time, but never actually used in this application of above ground flooding. And why would you want to do that? You might say, well, because we can speed up the process of flood spreading in urban areas. And this particular model has gone on to be developed much further since here, but in the early days, where we were looking, or the team were looking at how to exploit these cellular automata to save computational effort. And you can see the massive reductions in computational time by using a CADIS type model, whether you just use the CPU or even the GPU in the computer. I mentioned this one because it was a fellowship, my own fellowship, called Safe and Sure, towards a new paradigm for urban water management. Again, if you ever get the opportunity to have your own fellowship, I would really recommend it. It does give you that time and space to be able to think about subject over an extended period, and that's really, really valuable. Lots of things came out of it, but I just wanted to mention two. One was on the right there, we were looking at developing a qualitative framework for interventions. How can we improve the sustainability and resilience of urban water systems? And the Safe and Sure flower, as we called it on the right there, indicates the relationship between the threats, systems, impact, and consequences. And then it's a Venn diagram, isn't it? The intersections there show where we can intervene, we can mitigate, we can adapt, cope, and learn. And then on the quantitative side, we developed, and Chris Sweetapple as well, did a lot of the work on this, the global resilience analysis technique, allowing us to estimate the resilience of networks. And we were able to spot and in this particular case, identify critical sewer network, water distribution system networks in terms of their resilience or lack thereof. Another project here I picked because this was a more classical project which was experimental and computational, looking at masonry bridges, of which there are many thousands here in the UK, quite elderly masonry bridges that do suffer from scour on the piers, particularly under flood flow, bringing down large heavy material. And the team simulated bridge piers being struck by debris. And you can see a picture of the lab setup there, and the CFD model of the same setup, which had really rather remarkable agreement between CFD and experimental results. And again, that led on to design guidelines. I've included this one, 2017 and to 2021, because this was EPSRC fund, but also as part of the GCRF, which is the Global Challenges Research Fund. And this linked us up, although it's UK funded, with Indian partners, specifically IISC Bangalore, Indian Institute of Science in Bangalore. And the other reason I picked it was because we worked with Exeter with control engineers. So, and that's because we were looking at the benefits of UAVs, drones, under flooding conditions or post-flooding conditions. So we managed to link the deployment of drones via a decision support system, and then we modeled the flooding that had occurred and the evolution of the flooding over time to allow us to move the drone and anticipate where things might come to help with evacuation planning. A great project. Did get a little bit stalled right at the end when we got to the case study stage, or trying to roll it out in practice. COVID struck. So unfortunately, we didn't get right to the very end, but a lot of potential. And then another one, NERC this time, with DST, which is the Indian funders. So again, a link between UK and international funding, led by Fires Memon. Lots of good work in this project. Ones I want to mention is, it was about the fate and management of emerging contaminants, of which there, of course, are many. And we looked at developing a graphene-based treatment system. So again, working with colleagues in our department, but in the materials area. So we've got a graphene centre. And so showed lots of good potential. Developed in the lab here, taken out to India for pilot studies. And then at the same time, and in parallel, we developed a decision support tool for deployment of treatment techniques, and of course had some optimization in it as well. And then my final two slides, really linking up with where Dragan ended in his presentation, and that is with our doctoral training centres. You've heard already about WISE, and if you don't know what a doctoral training centre is, it's bringing groups of PhD students at any one time, cohorts. So it's driving a cohort together and much more integrated teaching as well as the research. And we've been really committed to that, and you can see the performance of the WISE PhD so far. We've got 50 through out the doors at the end with their completed PhDs so far, and still one or two more to finalise, and lots of journal publications. And in terms of metrics and outputs, I can give you even some more numbers, but I really just want to end with my final bullet point there. What we're dealing with is brilliant people. We want to produce brilliant people, and we've worked together with brilliant people. And I think, although we've looked at numbers today, we're looking at the technicalities of what we do. To my mind, this is our most important product. And I want to leave it at that. So thank you very much.
Any questions for David? Yes.
I'm just
No, he can't hear.
Thank you, David, for making a selection, quite an impressive selection of projects that we have been doing. I mean, the center has been doing over the years. I'm just picking up from the point where Ian left. Previously, we had a organic growth. Looking the future, is there a need to have a master plan, or we grow as we have been?
Yeah, that's a very fair point. I think as a group we have met a few times to do that, actually, to think about that. And Ian is here, I think, our head of department, head of engineering, and he certainly has a master plan for the department. And I think water figures quite strongly in that master plan. So I think it's a question of watch this space to see what is next.
As you're too early, this is a question for tomorrow.
That's future. Yeah, we're looking back. Yeah, no future.
Okay, so we leave it
We've got one more.
Okay, very well.
Thank you. Thank you, David, for a very interesting presentation. While we're thinking of future-facing comments, I was looking at your word cloud, and I didn't see the words climate or adaptation in them.
I think you've got to wait till later. So we're looking.
That was retrospective,
but we will look forward.
So you'll have a prospective word cloud as well.
Like a teaser.
Thank you.
Okay, thank you, David. And with that, we are moving on to the last speaker in this session, which could be me. So I'm going to talk about the international research, and I couldn't think of a better way of starting that presentation than to show you a world map. So these are the 102 countries that the Center for Water Systems have worked with. So we had project partners in those places, we had case studies, and most importantly, back to David's last point, CWS staff and students had an opportunity to travel the world and do collaborative research. So that was a great thing. My presentation will have two parts. I'll spend the best part of it talking about European Union funded projects, and then I'll mention a few more. To some extent, I'm copying the style of presentation that David prepared much earlier than I did mine. He's better organized. So I'm starting with the word cloud, and there is climate somewhere in it. As you know, European projects have acronyms that are either deliberately misspelled or are a wannabe funny way of producing the content in one word. So to avoid those, I selected only, when this was set up, only the 30 most frequent words we used for this word cloud. So you can see some new ones creeping in, such as climate and resilience and security and, of course, Europe. So that's there. I'm pleased to report that Centre for Water Systems have had 36 European Union funded projects over the years. It started with a couple of students doing an Erasmus project under the supervision of Godfery and Dragan. And then framework programs 5 and 6 had 2 full-blown, properly funded projects. And then in framework program 7, that grew significantly. So we were parts of, or we were leading some of the 10 research consortia. And then Horizon 2020 was really the golden period of European funding for us, when we had 12 projects. And the ongoing Horizon Europe project so far has 7 alive projects. Our participation in these projects typically, or our funding in those projects typically, was between €500,000 and €1 million, a bit less, a bit more. So long may that continue. So I'm going to say, again, in the style of the previous speaker, I'm going to say a few words about a selection of these projects with an overview for the programs. You can see the subjects that were covered here. So the Aquarec project looked at reuse of wastewater, and in it the decision to support tool was developed by the gentleman most left in this room. It simulated treatment trains. It considered constrained or unconstrained combinations of how water demand can be met by reclaimed water. That's the scheme you see on your right. And what you see on the left is a diagram of the life cycle cost of the system as a function of percentage demand satisfied. And from it, the outcome of typical analysis in this project was that through this kind of optimization, a much higher demand can be satisfied by reused water if this optimization tool is applied with the same level of investment. So that was the Aquarec project. The next one is new water, the FP6 project, where in one of the case studies, the client was Copenhagen Energy, and they looked at how to subsidize farmers so that they use pesticides not more than necessary, so that the impact of different practices through compensation comes to an optimal level in terms of how much they are paid through that compensation and how much the use of pesticides was reduced. And obviously that was all to do with reducing groundwater consumption. So what you see on your left is the scheme, how one thing affects the other in this system. And what you see on your right is some numbers that came out from the object-oriented patient belief network that was developed as a part of this project, which quantified all these things. So with Framework Program 7, sustainable water management became a sort of a new subject, and also looking at extreme events such as flooding. So I will say a few more words about a couple of projects from FP7. The first one is called Wassermed. In this project, the system dynamics modeling, more precisely the Simile tool, was used to look into water management in a number of Mediterranean countries on all sides of that wonderful area. Of course, under different climate scenarios. And the idea was to look at how climate change affects tourism and agriculture as key economic activities in this region. So the system dynamics model was run with monthly time steps for the next 40 years, which brought us then to 2050. And again, here you see the big scheme of things, how one thing affects another in this problem. And on the left, you see some of the results. The next project is COFU that I had the pleasure of coordinating. In this project, we developed a number of new methodologies for assessment of flood impacts, including damage on buildings and impacts on human health and impacts on traffic in cities. So we implemented this so-called DIPSIR, Drivers Pressures State Impact Response Framework. Excuse me. And what you see on this big image is the mega city of Dhaka in Bangladesh, where, as usual, different shades of blue indicate different flood depths, and green, yellow, and red indicate different levels of damage in wherever that happened, in more than 100,000 buildings that were captured by this analysis. And the important thing is, at the end of this project, we organized a big conference with people from 33 countries. Maybe 1/3 of those came from Asia. So that was a very nice event that some of you attended. And the last FP7 project I would like to mention is Saraswati. This project developed a tool for selecting optimal technology for wastewater treatment units combinations, which is, well, the list of those you can see here. And the tool uses multi-objective optimization to assess sustainability indicators, and then on the basis of that, identify optimal wastewater treatment technologies. And this also included scaling up. So this was a project with Indian partners. Horizon 2020, as I said, that was hugely successful in terms of research grants. New topics that were introduced here were, for example, geomaterials and resilience and nature-based solutions, Nexus, all those things that we are now seeing as, well, used very regularly. This is the project that Dragan referred to. It's looking at water, land, food, energy, climate, nexus in the context of strengthening critical infrastructure. I would just add or reiterate one, for us, very important thing, that on the basis of these results, not only the numbers, but also this wonderful visualization, Torbay City Council was awarded more than £3 million from the Environment Agency to actually implement what was recommended in this project. Sim for Nexus project implemented a somewhat similar approach with the addition of so-called serious game. The most interesting outcome of this is that if problem is looked for a perspective of only a single sector, let's say only water or only food or only energy, then the solutions are far from ideal. But by looking at all of these in a combination, or nexus as we call it these days, huge savings can be made and much better solutions can be identified. And again, the idea here is that a user, be it a manager or any kind of decision maker, can play with this serious game and reach better solutions. So there will be another presentation tomorrow afternoon, and there will be a demonstration in the Forum Street. So you will have a chance to meet the experts there. And then Next Gen is a similar thing. So the idea is this time specifically to introduce the concept or working within the context of circular economy, which is where we are now working with colleagues from the business school. So the serious game is coupled with the system dynamics modeling to demonstrate the circular economy of water. So this is the system dynamics causal loops, causal loops. And what you see here is a snapshot of the tool which can be used with all these colorful things to visually present to, well, both experts, but particularly non-experts, how that can be done. Horizon 2020, last project that I'll mention is Fiber for Water. So the important thing I would like to make here is that, I will run quickly through this one. The point I want to make is that what we were able to do with these projects is to have continuity, in the sense that in one project, we develop tools and methodologies, we establish networks, connections, reputation, and then once something like a referendum to leave the European Union happens, then we are still seen as valuable partners, and European partners have been prepared to take the risk of working with us. Those who were new in this game, after the referendum, they were typically told, well, when you rejoin EU, we'll work with you. But we were able to stay in that, which is illustrated by this last slide on European projects. These are all ongoing, so I'm not going to say anything about them, except that you can see their titles. So they are all yet to finish in the next few years, and we are still applying for Horizon Europe grants. A few words about other research. So those were mentioned in previous talks, some of them. Importantly, many of European Union funded projects had either targeted or spontaneously involved partners from Asia or Africa or other places, South America. Then we had co-funded UK, China, UK, Thailand, UK, India projects, or trilateral projects involving British Council. We had a number of self-funded or overseas government-funded PhDs, many of whom did a great job. So I spent some time thinking how to classify or systematically present this, but it was pretty much impossible, and it would be a bit of an overkill. So I'm just showing you again this lovely map. But I will say a few words about a couple of interesting projects in particular. So this one looked at solar power driven greenhouse for, agriculture that has its own desalination system that is driven by the energy produced from solar power. And it's interesting in the sense that, again, it was a proper research project in the sense that it had both the experimental and numerical modeling work, where there was a small prototype model in Exeter and full-scale one in Egypt, which is what you can see in the middle. And then, for example, the simulation you can see here is simulation of a ventilation of that space, which is an important element of, energy and whatever happens inside this greenhouse. And the last project I'm mentioning in particular is Enrich, which we did in collaboration with the Asian Institute of Technology in Thailand, which had two stages. The first one was focusing only on drought. The second one was looking at integrated drought and flood risk management. And it's a very large, 250 kilometers wide river basin. We ran climate change. The members of the team ran climate change models. Those were combined with modeling of land use changes, and on the basis of that, let's say, optimal agricultural policies were defined in collaboration with the Thai partners. From all this, which was mentioned earlier by our boss a few months ago, Times Higher Education listed the University of Exeter as the first globally in terms of actions and research on SDG 6, clean water and sanitation. That's probably the first time ever that Exeter University was ranked globally on any subject whatsoever. So we are very proud and happy to raise this flag. It's not only our center, of course, there are colleagues from other departments, as it was mentioned. It's also to do with what the university is doing internally in terms of, for example, water management on campus and things like that. But the single, group of people who contributed to this, that was the Center for Water